Hello students, welcome to Darasa Online. My name is Madam Joyce Goodluck Limo, Basic Mathematics teacher. Our today's topic is probability, and our subtopic is combined event. Welcome to listen the lesson. My dear students, our topic and subtopic will be guided by this outline here. These are the outline which will guide our subtopic of today. We will look on how to do the experiment concerning the combined event. Also, we will find the probability of a combined event by using formulas. And then we will see how to find the probability of a combined event by using tree diagram. After looking on all those three things, then I will give you an assignment. Try to do it at your own time. My dear students, the combined event, when we are saying combined event, what does it mean? When we are saying combined event, it means the situation of tossing two things at a time. Maybe you may have a coin at the same time having a die. Then you toss all those two things at a time. And when you're tossing those two at a time, you will obtain sample space or possibility set as the outcomes after doing the experiment of tossing those two things. My dear students, let's see how this combined event works. My dear students, when tossing two coins at a time, you have two coins, then you toss them at a time. You can try to toss two coins or two dice, or you can try one coin and one die. Then together you toss them at the same time. My dear students, let's start with the example of a coin. When you toss two coins at the same times, two coins, when you toss two coins at the same time, then how to find the possibility set? You can find the possibility set by using either a table or by using a tree diagram. By using a table, you have two coins which you have tossed. Then you draw your table and your table will contain two coins. Let's say this one will be your first coin and this one will be your second coin. So, when you toss these two coins, we know the outcome is either head or tail to be seen. So, when you toss the first coin, what will happen? It may be head or tail for the first coin. But when you are tossing the second coin also, what will be shown is head or tail. My dear students, then by looking on this table, first coin after tossed, you'll obtain head or tail. And also when you toss the second coin, also it will show head or tail. So you have these two coins, then you toss them at one time. You have these two coins, then you toss them at the same time. The result. First, the first coin may show head. The first coin may show head. Then we say the first coin show head. But when the first coin show head, the second coin may show head also. So you have the probability. When you throw the two coins at the same time, first coin show head and the second coin also show head. Or when you threw the coins together, the first coin may show tail, but the second one, which is this one, may still show head, because this is the outcome. So the first coin may show tail, but the second one is still show head. Or when also you toss these two coins, the first one may show head, but the second coin may show tail. So you'll see that the first coin, when it show head, the second coin will show tail. Or when you toss the coin together, the first coin show tail and also the second coin show tail. So my dear students, we'll have this possibility set. So the possibility sets obtained are these here. These are possibility sets. So my dear students, these found here are the possibility sets. We can write those possibility sets as when we toss these two coins, when the first one show head, also the second coin show head. Or when the first coin show tail, then the second coin still show head. Or when we toss the coin, the first coin show head, while the second coin show tail. And then the last, when the first coin show tail, then the second coin will show tail also. So these are the possibility set. These are the possibility set. And these are the possibility set in a combined event. So the possibility set in a combined event, we see there are two things which are combined. Head, head, tail, head, head, tail, tail, tail. So these are the possibility sets. Then we can say that the number of possibility sets, which is S, number of possibility sets is equal to, we count the number inside this bracket. How many are they? 1, we say this 1, 2, 3, 4. So the number of sample space equals to 4. So this is how to find the sample space of a combined event when you are given two things at the same time. Also, this is one example of finding sample space by using a table. You can find also the sample space by using tree diagram. My dear students, finding a possibility set or sample space by using tree diagram. In tree diagram, we will have a starting point. Then our starting point, let's say this is our starting point of drawing our tree diagram. So the starting point is where you have your maybe 2 coins or 1 coin, 1 die or 2 dice. Then you have it. So starting point is the time you are starting to toss those 2 things. So this is the starting point. You can say this is the start. At the first, when you toss the coins, our tree diagram here is concerned with 2 coins. So we'll see, we have tossed 2 coins. That will be our tree diagram. So we have the starting point, then we toss our 2 coins in the starting point. We know that these are the branches. You know the tree has to have the branch. So these are the branches. Then this branch should come from the first coin. That when you toss the coin, at the first time, the first one should show either head or tail. Then we say that the first coin, should show head or tail. After seeing that the first coin show head or tail, then the second coin will show. Maybe when it was head on the first coin, the second coin may have shown head or may have shown tail. So this should be on the second coin. But if when we threw 2 coins together and the first coin show tail, so if the first coin show tail, then on the second one should show head or tail. So we see that this is the tree diagram. The tree with the starting point, then the first coin contain head and tail. Then we have the second coin contain head and tail, Then from our tree diagram now, we are going to obtain the sample space. Sample space should be obtained according to the branches of this tree. That is possibility set. The first branch, when at the starting point was here, then the first coin show head, then the second one show head or tail. So then you start with the first branch, this one. You'll come from the first coin, there is head, then continue to move to the second coin, shows head. When you come to the same starting point, we have the second branch here. We also start from the beginning. This is our starting point. Then we move to the same direction that one coin, the first coin show head. Then from head, we have already choose this one. Then we are coming to the second branch here. That's from head to tail. So these are the 2 branches obtained from the first coin and the second coin. Then we come back to the starting point. We are moving now to this branch, look downward here. Then from the starting point, the first coin, when it shows tail, then we move this tail, but from tail, it moves to the head, that is the second coin. So the first coin show tail, then the second coin show head, then it will be H. Then coming back to the starting point, the first coin, when it show tail, then we have this another branch here. That first coin show tail, then the second one show tail, then it will be T, T. So these are our possibility set. That is head, 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 tail, tail, head, tail, tail. So this is the possibility set by using tree diagram. Also, the number of sample space will be the same, which is equals to 4. My dear students, so this is how to find a possibility set by using a tree diagram. After seeing how to find the possibility set by using tree diagram, let's look on the example of a die. My dear students, the second example is about a die. Possible outcome when rolling two dice at the same time. Here we are looking at two dice. The first one we are looking at two coins. Those are the combined events. And now we are looking on two dice which also are combined events. So, finding possibility sets of a die. We can also use a tree diagram or you can use a table. Those two things will help you to find the possibility set when two dice tossed together. Let's see example by using a table. We have two dice. Then we need to find the possibility set. In order to obtain this possibility set, we'll have to draw the table, which will show us the outcomes after rolling dice. And we know what is a die from the previous lesson. Die is something which contains 6 numbers. It contains 1, 2, 3, 4, 5, and 6. So when you are rolling those dice, it can show the different number 1 or 2 or 3 up to 6. Then we draw the table. Our table will contain first die, and on this side we'll have second die. Then when you toss first die, the possibility of number to occur, there is possibility of 1, 2, 3, 4, 5, and 6. These are the possibilities of outcome to occur when you toss a die. Even in the second die, when you toss it, the possibility outcome to occur is 1, 2, 3, 4, 5, 6. Then, my dear students, by looking on our table, we have a table which shows dice which are rolling together. So, when you roll these two dice, the first die may show 1, and the second die also show 1. But when you roll again, the first die may show 2, but the second one may still show 1. So we say that when you roll the first die and second die at once, here it may show 1 or 1, or the first one may show 2, but this second one may show again 1. The first may show 3, but this one may still show 1, 4, 1, 5, 1, and 6, 1. So this is the possibility that all the variables in first die may show different numbers, but on the second may show only one number, which is 1. Or when you toss the second time, you can see on the first die may show 1, but on the second die may show 2. Then, when the first die also show 2, then the second ones may show 2. When the first one show 3, the second one still show 2. When the first one show 4, the second one still show 2. When the first one show 5, the second still show 2, 6, this still show 2. It's continued this way up to the last number, that is and the last one also may show 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6. My dear students, after seeing this table of possibility set, these are the possibility set. These are the possibility set to occur. You can write them as this example here. That possibility set of tossing 2 dice is 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, up to 66. These are the all possibility set. So if all of these are possibility set, then what is the number of possibility set? My dear students, from this table, then we will obtain the number of possibility set. Number of possibility set equals 2. What you are supposed to do, you have to count the outcomes. You have to count the outcomes after tossing those 2 dice. This is the first outcome, this is the second outcome, third outcome. Then you count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to the last one will be 36. Then we say the number of possibility set equals to 36. Then from there, you can find the probability of combined events, which will be given by using number of sample space and the number of events which will be asked. My dear students, finding the probability of a combined event, we will find it by using formula. But this formula will come from 2 concepts. By applying those concepts will enable you to find the probability of a combined event. Those 2 concepts is 1, the first concept is mutually exclusive or disjoint events. That is the first concept. And the second concept is independent event. So these 2 concepts will enable us to find the probability of a combined event. Then let's check on mutual Let's check on mutually exclusive events. What does it mean when we say mutually exclusive events? Mutually exclusive events, this means that when you have 2 events, and these events they cannot occur at the same time. Let's say event A and event B. That is you have two events, event A and event B. But this event, they cannot occur at the same time. They cannot occur at the same time. That is, event A cannot occur at the same time with the event B. What does this mean? Let's say you have a single coin. We know that when you are tossing a coin, you have the possibility of obtaining a head or a tail. So these are the two events. So when you toss that single coin, there is no possibility of obtaining head and the tail at the same time. That is what we mean by mutually exclusive. It means when you toss that single coin, it's either only a head shown or a tail shown, but not all of them at the same time. So the probability of this mutually exclusive. So the probability of mutually exclusive, one of the event. It depends with one of the event. Also, having a die. You cannot toss a die and at the same time the top of the die shows even number and the odd number at the same time. No. That is what mutually exclusive event. That when you toss a die, if at the top it is even number, it must be only even number. If it is odd number, also it must be odd number, but not even number and odd number. So mutually exclusive event, it means that the probability of event 1 cannot occur at the same time with the event 2. My dear students, so by seeing those examples, we can say that mutually exclusive or disjoint events, they cannot occur together. They are different. If this one occur, then this one will not occur. And if this one occur, then this one will not occur. And these mutually exclusive events lead us to law of probability, which is addition law of probability. My dear students, then this mutually exclusive events or mutually exclusive disjoint events lead us to the law of probability. That law of probability is known as addition law of probability. Addition law of probability. Addition means summation. So the addition of law of probability is given as you have two events. That is event A and B. According to mutually exclusive that this event cannot occur at the same time, then we say that probability of A or B equals to probability of A plus probability of B. Probability of A or B, it means that either probability of A to occur or probability of B to occur. That is, probability of A or B equals to probability of A plus probability of B. And by formula we say probability of A, then O is this sign. This is the symbol of O, as used in Form 2 in topic of set, that this is union. But here in probability, this is O, B, equals to probability of A plus probability of B. So this is the formula which comes from the concept of mutually exclusive events. And by using this one, you can find the probability of an event A to occur while event B does not occur. But when these two events, that event A and B, have the same element, you find that event A and event B have the same element, then we can use the concept of set as learnt in Form 2 class, that in set. By using this concept here from Form 2, then in probability, if the event of A and B elements are the same, we can say that probability of A union B equals to probability of A plus probability of B minus probability of A intersection B. And this is useful only when the elements of event A and event B are the same. If these elements are the same, then you can use this formula. But if they are not the same, our formula is this one, that probability of A or B is equal to probability of A plus probability of B. My dear students, let's look on the second concept. My dear students, let's look on the second concept, that is independent event. Independent event, here we say that two events are independent if they can occur at the same time. Two events are independent if they can occur at the same time. This means what? When you have two events, then the occurrence of the event 1 cannot affect the occurrence of the second event. So this event can occur at once at the same time. That is independent event. That is independent event. You have two events. You have two events, that event A and B. These are the two events. So the occurrence of this event cannot affect the occurrence of this event. So this event, they can occur at the same time. Example, when you have two dice, you have the first die and the second die. When you toss these two die 1 can show 1 while die 2 can show 3. So we have seen that the occurrence in first die did not affect the occurrence on the second die. Or when you toss two coins, the occurrence of head on the first coin cannot affect the occurrence of tail on the second coin. So independent event, it means that occurrence of one event does not affect the occurrence of the other. My dear students, after seeing how this independent event works, then this independent event lead us to the multiplication law of probability. This is multiplication law of probability. multiplication law of probability say that if we have two events, that is event A and B, then the occurrence of event A will not affect the occurrence of event B. This means events A and B are independent events. Then that will be equals to probability of event A and event B equals to probability of event A times probability of event B. So this is independent event. Or we can remove this word and put a symbol, which is intersection symbol, as lent in form 2. Then we say probability of A and B equals to probability of A times probability of B. And this is the formula which you use to find the probability of a combined event when the two events are independent. After looking on our subtopic of combined events, we have seen the formulas to use when solving different questions of a combined event. You have seen how to use a tree diagram to solve combined events and how to find the possibility set. So let's look the model questions on how to solve this question. My dear students, we have questions which will guide us to understand better the combined event. Question number 1. 2 dice are rolled once. 2 dice are rolled once by tree diagram. What is the probability that the sum of the scores of the 2 dice is part A exactly 8, part B at least 9, part C at most 4, part D more than 1, part E more than 12. My dear students, here we need to find the probability. And our question instructs us to find the probability by using a tree diagram. So we have to draw a tree diagram. Our tree diagram will be on 2 dice. So our diagram contains 2 dice, the first one and the second one. So we have to have the starting point. This is the starting point of our dice to be rolled. So the starting point, when you start to roll these 2 dice, the first die may show those 6 different numbers. This is 1, 2, 3, 4, 5, and 6. This is a possibility of the first die. Then we say this is the first die. Then in the possibility of the second die, the possibility of the second die will be shown like this one. When the first die show 1, the second die may show all the other options. That is, may show 1, may show 2, 3, 4, 5, 6. So this is second die. That is the option. Or when the first die shows 2, the second die also may show the option, all the option 1, 2, 3, 4, 5, 6. The same to the third. Then the second die may show 1, 2, 3, 4, 5, 6. The same to first die showing 4. The second one may show 1, 2, 3, 4, 5, 6. The same to the first die showing 5. The second one will show 1, 2, 3, 4, 5, 6. Then to the last number will show 1, 2, 3, 4, 5, 6. So this is the tree diagram. Our tree diagram will show the two dice. The first one showing 1, 2, 3, 4, 5, 6. And the second one showing the different numbers on a die. Then we need to obtain a possibility set. We will have to obtain the possibility set in order to answer our question. The possibility set S equals to, when we are going to take this possibility set, we'll start with the first one with the second one. So the first die when it shows 1, the second one shows 2, 3, 4, 5, 6, up to 6. That is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. When the first die shows 2, the second one will show this 6 option. That is, when first one shows 2, the second one may show 1, 2, 1, 2, 3, 2, 4, 2, 5, 2, 6. The same, when the first die shows 3, the second die shows this 1, 2, 3, 4, 5. Then it will be 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. When it is 4, it will be 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and 4, 6. When it's come to first die shows 5, the second die will show all these options. That is 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And the last one, when the first die shows 6, the second one shows this option. That is 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. When you count 1, 2, 3, 4, 5, 6, 6 times 6, then the number of sample space equals to 36. Number of sample space equals to 36. Then we are going back now to the question. What is the probability that the sum of the scores of the two dice is exactly 8? What we are supposed to know? The sum. It means when you add two variables from the first die and the second die, the answer should be exactly 8. Then we come to the sample space. We are finding the number. When we add up them, we obtain exactly 8. From the first row, there is no number you can add to obtain 8. But the second one, there is 2 and 6. 2 plus 6 is equal to 8. The third row, there is 3 and 5. 3 plus 5 equals to 8. The fourth row, there is this one, fifth row, this one, and the sixth row is this one. So we have this to add up to exactly 8. Then this will be the event. Events is exactly 8. So number of event 1, 2, 3, 4, 5. Then the number of event is 5. So the probability of event equals to number of event over number of sample space, which is equal, number of event is 5, number of sample space equals to 36. So this is the probability of exactly 8. Part B. What is the probability that the sum of the scores is at least 9. My dear students, when we say at least 9, we mean that it is 9 or above 9. So we are finding the number. When we add them, the answer should be 9 or above 9. Then we start counting. On the first row, there is no number, even on the second. But on the third, we have this one, 3 plus 6. We have 4 plus 5, 4 and 6. We have 5 and 4, 5 and 5, 5 and 6, 6 and 3, 6 and 4, 6 and 5, 6 and 6. So we are looking our events. At least 9. Then the number of events equals to at least 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 10. So the probability of an event is equal to number of events over number of sample space. That is 10 over 36. You can simplify by 2, 5, by 2, 18. So this is the probability of an event. Part C, at most 4. Part C, at most 4. The probability of getting the sum at most 4 means you obtain 4 or less than 4. That is the means of at most 4. So if it is 4 or less than 4, we are finding the first row we have 1 plus 3 is 4. And less this one. So this one will be 1, this one, this one. 2 plus 1, 3. Sorry, this is 2. 2 plus 2, 4. 3 plus 1, 4. But here 4 plus 1 is 5. So this will not work. Then we have 1, 2, 3, 4, 5, 6. Then we say the events, part C is at most 4. Then the number of events equals to 6. Then the probability of event equals to number of events over number of sample space, which is equal to 6 over 36 when you simplify 1 over 6. Then in part D, we have more than 1. More than 1, when you add a number, it is more than 1. So all these numbers, when you add them, the answer is more than 1 because the first number on the first column and the first row is equal to 1, 1. So 1 plus 1 is 2. If this is 2, it means all this, when you add up, the answer will be more than 1. So the number of events here will be 36, and we have our number of sample space, which is 36. Then the probability of event equals to number of events over number of sample space, which is equal to 36 divided by 36, which is equal to 1. Then the probability of an event more than 1 equals to 1. Then part E, the probability when the sum is more than 12. My dear students, in our possibility set, there is no number which you can add and obtain the answer more than 12, because on the last row of 6, there was 6, 1, 6, 2, up to 6, 6. When you add this last number, 6 plus 6 is 12. And this is not more than 12. And the question says we find the probability of getting more than 12. So their number of events equals to 0. Then the probability of an event equals to number of events over number of sample space, which is equal to 0 over 36, which is 0. So there is no probability of the variable adding to more than 12. My dear students, after seeing the example of a combined event, now I will leave you with an assignment so as you can try to do it. The assignment, question number 1, a card is chosen at random from a pack of playing cards. What is the probability that it is, part A, a red, part B, a queen of spades, part C, either a diamond or a club. Question number 2. A number has 3 different digits formed by arranging 3, 5, and 8. Without repetition, A. Write down all possible numbers. B. What is the probability that the number is divisible by 5? My dear students, I hope you will try to do those questions, and also you can search more questions in different books or even in internet. Thank you very much and welcome on the next lesson.